Until now, we often pictured motion along one straight line. A body moved left or right along a road, so one coordinate axis, usually the x-axis, was enough. But real motion often spreads across a plane. A person may walk east and then north. A footballer may run along the length of a field and then along its width. A chess knight moves two squares in one direction and one square perpendicular to it. A car may follow city streets that meet at right angles. These are examples of motion in two dimensions. Distance traveled and displacement must still be kept separate. Consider a person who walks 40 meters north, then 30 meters east. What is the distance traveled? For distance, follow the actual route. The person walks 40 meters, then another 30 meters. So the distance traveled is 40 meters plus 30 meters, which equals 70 meters. Distance follows the two legs of the route. Displacement does not follow those legs. It is one straight arrow from the initial position to the final position. The two parts of this route form a right triangle. One leg is 40 meters, and the other is 30 meters. The straight connection from start to finish is the hypotenuse. Its length is the magnitude of displacement. We can find that length with the Pythagorean theorem. The magnitude of displacement squared equals 40 squared plus 30 squared. 40 squared is 1,600, and 30 squared is 900. Their sum is 2,500, so the magnitude of displacement is 50 meters. For this motion, the distance traveled is 70 meters, while the magnitude of displacement is 50 meters. Keep this mental picture. Distance runs along the actual route. Displacement cuts straight through the plane from start to finish. For two perpendicular parts of motion, distance is the sum of the two traveled legs, while the magnitude of displacement is the hypotenuse. But be careful, displacement is not always the hypotenuse. That description works when the two parts of motion are perpendicular, so the route and the straight start-to-finish connection form a right triangle. A football field gives exactly this geometry. If a player runs along the length of the field and then along its width, the distance traveled is the sum of those two sections. The magnitude of displacement is the diagonal of the rectangle. A chess knight gives a smaller scale example. Its move goes two squares in one direction and one square in a perpendicular direction. The magnitude of displacement is not 3 squares. 3 squares would come from adding the two perpendicular separations as if the knight followed an L-shaped route. Displacement is the straight distance between the initial and final squares. Suppose each square is 3 centimeters wide. The perpendicular separations are then 6 centimeters and 3 centimeters. The magnitude of displacement equals the square root of 6 squared plus 3 squared. That is the square root of 45, or 3 square root 5 centimeters. The physical meaning is simple. When a body moves in two perpendicular directions, add the actual parts of the motion to find distance traveled. To find the magnitude of displacement, use the straight distance from the initial position to the final position. In a problem, draw the situation before searching for a formula. Mark the start and the finish. Trace the actual route. Check whether the parts of the motion are perpendicular. Then decide whether the problem asks for distance traveled or for the magnitude of displacement. For distance traveled, add the parts actually covered. For the magnitude of displacement, find the straight separation from start to finish. If this explanation helped, please like the video, subscribe to the channel, and leave your physics question in the comments. We will do our best to answer it.